So here we're told that the mass of living organisms in a lake is defined to be the biomass of the lake. Okay? If the biomass in a lake doubles each year, which of the following graphs could model the biomass as a function of time? So let's look at our options. First of all, just looking at all of them, we can already eliminate D just because here the biomass does not increase over time, even when we need it to double each year. So D is out. What about these remaining ones? Um, so looking at the first one, we see that at point, okay, so it starts with, the very first year, it's 1, 1, then 2, 2. So here it seems to double. However, you got to be careful because, first of all, it goes from 0 to 1. That's not doubling, right? So if you start at 0, no matter how many times you double it, it'll still be 0. So that's a little bit inaccurate. Not a little bit, that's, mathematically incorrect. But also you notice that, after 2 years, at year 3, it should double from 2 to like 4, right? So that would assume sort of like an upward curve, but that's not what we see because it's just a line. So for these two reasons, A is eliminated. Again, I think the easiest way to think about it is just that if you start at 0, no matter how many times you multiply it by 2, you'll still be at 0. So this graph does not show biomass doubling each year. B. First of all, we again start at 0. So no matter how many times you double this, it'll still be 0. So this can't show something doubling each year. But also it's just a little bit, well, does it actually work out? 2, 2, 1, 1. Okay, so it seems to work out mathematically at the points 1, 1, 1, and 2, 2. However, it's not a very good model for, which of the following graphs could model biomass. This probably isn't a very good model for biomass, simply given that, mass doesn't increase at, it doesn't increase instantaneously by, half a ton. Because in this graph, it increases by about half of a ton in no span of time. And here, again, sort of instantaneously shoots up. So this could also not model increase of biomass. However, C could. First of all, we notice that it doesn't start at the origin. So if you multiply this value by, which looks to be about 1/2, right? So if you multiply it by 2, that actually won't be 0. So you can actually start with this as it's showing and then double that each year, which is exactly what you see. You're starting at roughly 1/2. You double it to 1, then that doubles to 2. And it's a continuous gradual curve as opposed to having, spontaneous increases of biomass like shown in B. So for that reason, C is our answer.